In 10E, we have another rational inequality. Again, we'll abide by our same rules. We do not want to use the LCD because it's an inequality. So we'll have 3x all over 2x plus 1 minus 4 over 2x minus 1. We want to get one side equal to 0, so we'll go minus 1 has to be greater than or equal to 0. And this is a 1 over 1, so we want to get a common denominator and write it as a single rational equation. So these are grouped by the division bar, so I know that in my common denominator I need a 2x plus 1, I also need a 2x minus 1, and that's my common denominator. This multiplying by 1 will not change it. So what I want to do is create a common denominator, so I would have to multiply this denominator times by the 2x minus 1. Whatever I do to the bottom, I do to the top, so 2x minus 1. So really I have a 3x times 2x minus 1 minus 4. In order to create a common denominator for this fraction, I have to multiply top and bottom by 2x plus 1. So 2x plus 1. So it's going to be negative 4 times 2x plus 1. And then finally, on the 1, I'd have to multiply both top and bottom by 2x plus 1. That's a terrible writing, but I'm going to multiply both of them by 2x plus 1 and 2x minus 1, both top and bottom. So, in this last one, it's minus 1 times 2x plus 1 times 2x minus 1. That's all over our least common denominator, and it has to be greater than or equal to 0. Well, that was a lot of fun and joy, but let's see what else we can dig up. This is going to be 6x squared minus 3x, then minus 8x, then minus 4. Then we've got a minus, and subtract this binomial times another binomial, so FOIL, so minus this entire product of those two binomials, which is 4x squared. Then we got a minus 2x plus 2x, that's nice at least. So they'll cancel, and our last will be minus 1, greater or equal to 0. That's over our common denominator of 2x plus 1 times 2x minus 1. Now we'll go with another round of simplification here. So now what I want to do is take my 6x squared minus 3x. I guess I could simplify those as long as I'm going along this path. These two are like terms, so minus 11x minus 4. Then I want to distribute, so it's going to be minus 4x squared plus 1 all over our common denominator of 2x plus 1 times 2x minus 1, and that has to be greater than or equal to 0. So we got to make another round of simplifications here. So the 6x squared and the 4x squared is going to be a 2x squared, and then minus 11x, then minus 3, if I clean that up correctly. And that's all over our least common denominator of 2x plus 1 times 2x minus 1. That has to be greater or equal to 0. Now what we'd like to be able to do is put it in, well, our first goal is accomplished. We have gotten it as a single rational expression, set equal to 0, or at least one side equal to 0. And now what I'd like to be able to do is be able to factor this numerator so I would be able to find the zeros of the function. But the problem is between 2 and 3, it's awfully hard to build an 11, so what this formulary beast is one of these non-factorable quadratics. So in order to find the zeros of this function, we're going to have to use the quadratic formula. So it's the opposite of b, which is 11, plus or minus the square root of 11 squared. Negative 11 squared is 121, minus 4 times 8 times c, so that's going to be 4 times 2 times negative 3, or plus 8 times 3, 24. And that's all over, or each over, however you like it, 2a, which is 4. So it's going to be 11 plus or minus the square root of 145 all over 4. And unfortunately, this 145 does not simplify to anything great. So what we need, and our goal is to, if you keep this in mind, is to break up this number line into intervals. And I really need to know where these intervals are. Well, I'm going to come back to this in a second, but I'm going to show you why I'm not going any farther with that at the moment. I'm just going to simplify that as a decimal. I know that the vertical asymptotes are at a negative half, so if I just consider that this is a negative 1/2, and the other one is at a positive 1/2, so I'm just going to put that over here at a positive 1/2. Those are the vertical asymptotes. I need to know the approximate location, or the location of the zeros. Well, if I write this in simplest radical form, it's not that telling for me. So what I'm going to do is I'm just going to plug this into the calculator, and I'm going to say, give me the decimal approximations of where these occur. And this is going to be 11 plus the square root of 145. I'm going to take that whole expression, divide it by, sorry, I only want to do the plus 1. So I'm going to do the plus 1 here first. So it's 11 plus the square root of 145 divided by 4. And then I'm going to do another one where I do minus. So it's 11 minus the square root of 145 divided by 4. And I'm going to get the decimal approximations for each of those. So when I take 11 plus square root of 145, which is awfully close to a 12, and a 12 plus 11 is 23, and a 23 divided by 4 is really close to, and above a 5 and less than 6, so this one approximately is 5.76. Okay, so in this one, if I do the calculations, is awfully close to a negative 0.26. Now don't get too bitter before you start telling me how we never use decimals. The reason I don't want the exact values out here is I don't have to get wrapped up in that. It's just going to divide my line into another set of intervals. So one other interval is out here at 5.76. So now I've got some intervals being created there, and I also have a negative 0.26. So a negative 0.26 is going to be in between our negative half and our positive half, so I'm just going to put it in here as a negative 0.26. These are the zeros, and then we also have the vertical asymptotes. Now look at how many different places we've divided this line up into. Interval 1, we have another interval from here to here to our 0. We have a third interval between zeros and vertical asymptote, and again here. And our fifth interval is out here. So we've got 5 intervals to check and to make sure that we can get our signs. So because this doesn't factor with Kahoot, it makes it a little bit more fun and adventuresome to put in intervals. So I'm going to put in a number like negative 1. If I put a negative 1 and square it, that's positive. So it's 2 times 1 or just 2. And then a negative 1 times a negative 11, that's positive. So plus 11, then minus 3. So my numerator is definitely positive over. And then I got a negative 1 times 2 is a negative 2 plus 1, which is negative 1. So now I'm working on that denominator, negative 1. Then I put a negative 1 here, and that's going to be another negative for sure, because it's negative 2 minus 2. And negative times negative is positive. Positive divided by positive is positive. So I got the first big one done. In that interval, it is positive, and they typically start to alternate. So I would expect negative, positive, negative, positive, and nothing should impact that positive negative altering because there's no squared, there's no volcano graph being drawn by our factors. So I'm pretty sure that I've got those. I don't have to do the entire interval notation on every single one of those. So now I'm going to look for the intervals in which it is greater than or equal to 0. So I definitely have an interval out here at negative infinity up into negative 1/2. So from a negative infinity to a negative 1/2, but negative 1/2 is a vertical asymptote. We can't use it, so we go up to that. We want to union that with the next positive interval goes from this negative 2.6, so parenthesis, negative 2.26, sorry, union. And next thing I better get straight is it's actually equal to 0 there, so at a negative 0.26. Now this is where it'd be nice to have those exact values, and this would be that 11 minus the square root of 145 divided by 4, comma, and we go all the way to a half, but again, a half is a vertical asymptote. We can't use it, so we use a parenthesis on that end, so union that with the next place that is positive is anything bigger than 5.6 and equal to, so square bracket 5.76 to infinity, and again this 5.76 is 11 plus the square root of 145 all over 4. So that problem is a nice problem. It's just dandy. Hopefully you enjoyed that little mission in life. 9 minutes and 40 seconds later, I've hopefully discussed all the things that you need to know about that question.